Off. So I'm going to skip this slide. You guys already know the standard disclaimers. I feel like I have to put this one out there, but obviously opinions are my own, not of my employer, which is my company in this case. But so with that, who am I and why should you care about what I might have to say about this topic on Gen AI? So my background is very technical. I launched global apps at Uber, worked at Facebook back in the day, have published research on distributed architecture for networking systems. So tech AI is really my bread and butter. And over the course of the last year, we've worked closely with medical affairs as well as regulatory affairs on really trying to understand what kind of challenges and problems can really be addressed with AI. So that is a little bit about my background. And all right, so what we're going to do in this presentation is we're going to go through and cover the fundamentals of what is Gen AI, what are the limitations of Gen AI, because it's really important to understand the core before we dig into how do we actually apply Gen AI to various use cases. So with that, the fundamentals, what is Gen AI? You guys have heard about it, I'm sure, with ChatGPT. Probably most of you have also heard of the concept of large language models, which is primarily kind of the subsect of Gen AI most folks are really familiar with. And the way to fundamentally think about large language models is that they're trained on volumes of unstructured text, and they kind of learn patterns of words and are able to then generate text, right, which is in the name, but also they're able to analyze patterns of text. And the other kind of high level technical concept I want to cover that most often you probably haven't heard of is this concept of encoder and decoder type of models. And the simplest way to think about it is that encoder models encode or analyze. So these types of large language models are great for analysis of text. So think analyzing publications as an example. But on the other hand, decoder models decode or generate. So the OG ChatGPT, GPT 2.0, way back in the day, was actually a decoder model. So really the power of Gen AI is not just about generation, it's actually about analysis as well. And if you're able to combine the two, I think that's really where the high ROI and the true value comes in handy. So with that, I think the other important thing to highlight is to understand why Gen AI is different. Because if we understand why it's different, we get to understand what new possibilities this technology unlocks. Because AI has been around for a really long time, right? I mean, many decades. So why is Gen AI all of a sudden this new thing? And what could it really enable that wasn't possible before? So to kind of think about it from a perspective of life sciences, the way that I like to break it down at a high level is to think about almost like three waves of digital transformation that life sciences has undergone. The first wave was really just simple digitization. So, the FDA, for example, allowed electronic submissions maybe 8-9 years ago, where you don't have to mail in physical paperwork, right? So 8 years ago is not that long. And that was just in wave one. So moving on to wave two, after the digitization was established, we started to see kind of what I would call as, ML, machine learning, AI 1.0. And a lot of those types of AI applications, I would say, were generally focused on kind of learning on discrete units. So what I mean by that, and I'll use an analogy here, is let's say I'm trying to build a house and I'm laying the house brick by brick by brick. So the AI model can look at that brick, look at the next brick, and then maybe predict the brick after. So it's kind of focused on very singular discrete units. It was almost very decision tree focused and basic, even though it's not basic. So that's maybe the wrong way of framing it. So with wave three, with generative AI, the way to almost differentiate it and think about it is really two things. One, rather than focusing on discrete units, it focuses on patterns. And two, it's able to generate, right? So it's able to be quote creative and generate different types of patterns, which it can learn from. So in the house analogy, you can think of it as if I'm building a house brick by brick, but those bricks could be blue, green, yellow. Maybe I decide to lay the bricks in a circular format. So in a way, these Gen AI models can learn patterns versus just individual discrete blocks. And one way to illustrate that is through search. And I'm going to use this example of, let's say you wanted to go on Amazon today and buy a Monstera plant, which probably you guys are all familiar with. So in wave one, right, the digitization piece, that would be, I have the physical plant, I take the photo of it, right? That's probably the most basic form of digitization. In wave two, or kind of that discrete version of AI, if you guys know today, whether you go on Google search or if you go on Amazon and you start typing Monstera plant, you will see like the autocomplete, right? So that is like wave two AI models where it could predict the next letter or maybe how your word ends. And in that wave, you effectively had to almost specify a Monstera plant can also be called a Swiss cheese plant or Monstera deliciosa. So that way, if I'm trying to buy a plant, I can search any of these terms and the AI model would be able to kind of detect that you're referring to the same thing. While in wave three, because Gen AI models are able to recognize more patterns, you can think of it in the context of the Monstera plant as there's many ways to describe a Monstera plant. Looking at this photo, I could call it a large plant with green leaves with perforations, or a large plant with big leaves with holes in them, right? So a Gen AI model can kind of learn these bigger patterns, and because it can also generate new patterns, so you could ask it, tell me ways to describe the Monstera plant, and it would probably tell you 50 different ways. It can also learn from those. So it's able to understand, I guess, more complex ways of searching in our Amazon example. So hopefully that's kind of helpful in just laying out how Gen AI is a bit different than other waves of AI. So that's kind of the foundations of what is Gen AI and how to think about it. And on the alternative side, before we get into use cases, we really fundamentally have to understand what are its limitations. And these 3 bullet points I've listed here are common misconceptions, I think misunderstandings that I see across the industry, and we're going to dig into this. And I'm sure if some of you have played around with ChatGPT, even for personal use, likely you have some of these concerns. For example, is it making stuff up in the response? How accurate are the answers that are being returned to me? Are the answers that are being returned comprehensive? So for example, if I ask ChatGPT, give me all clinical trials for Ozempic, is it returning all of the clinical trials? Like, is it going out there and searching for all of them and then returning them? It's actually not. So, in theory, that answer that it's going to give you is likely not going to be comprehensive. So I think understanding how to enable comprehensiveness and why Gen AI is not comprehensive always is important. And then kind of the last element that I oftentimes see is, folks kind of assume because ChatGPT can do cool stuff that it's almost like AGI. It can solve all my problems. I can, can go through millions of literature publications and find exactly the signal through the noise of what I'm looking for. While Gen AI can be an ingredient into enabling some of those use cases, it's certainly not the only ingredient in that recipe to do so. And I think there's an important need to distinguish when only ChatGPT can be used versus when do you need a set of tools to enable the outcome you want. So we're going to dig into these 3, and then we'll jump into use cases. So hallucinations. And I'm curious, actually, are you all familiar with hallucinations? Have you heard that term before, or is this the first time that you guys are hearing of the term? If you want to leave a comment, that would be awesome. But so AI models, in particular, Gen AI models can hallucinate, but not the other type that we know, so to speak, in the industry. So hallucinations, what are they? Well, in lay terms, effectively hallucinations is when a Gen AI model speaks false but plausible knowledge, likely so confidently that it seems like it's saying something that's really accurate. In other ways, it makes stuff up. So to illustrate why this happens, we're going to walk through an example. So let's say we ask this model, ChatGPT or another large language model, what causes diabetes? And let's say our ideal accurate answer, that's a lay response, would be that diabetes is primarily caused by a combination of genetic and environmental factors, including obesity and lack of physical activity. So generally, this is true. It might not be like medically, technically in depth, but let's say for this example, it's accurate. But what if instead the model responded with the following? Diabetes is caused by eating too much sugar, and reducing sugar intake can cure it completely. Obviously, this would never pass the MLR review or ad promo review, and it's just completely false. But why might the model come up with this response? So, at a high level, why that happens is because large language models like ChatGPT, Copilot, or any other tool you might be using are in fact not knowledge and fact learning models. They don't logically reason. They are purely language models. And what that means is these models are built statistically correlating which tokens or words, is a simpler way to think about it, go with other words and how those words correlate with your input. So, using the diabetes example, why it might have come up with that answer is because when the model was trained on the text, it saw that sugar intake and those types of words occurred with diabetes or what causes diabetes. And because those are statistically correlated with your question, it generated this response. And because it was trained on information that could be considered false information, right, it naturally just kind of pops that out. So it's important to distinguish again that large language models, they're not fact learning models. They're not sitting there, searching through medical literature on diabetes, synthesizing, doing logical analysis on what causes diabetes. They're literally pattern matchers. So it's like, oh, sugar was associated with diabetes. Okay, let me spit that out into a sentence that sounds plausible. So really, really important to know. So if you're using ChatGPT internally, if you have an enterprise subscription, just make sure, the content that's ultimately being generated, you are double checking, knowing what you know now. There's ways to address this, but I think it's really, really important to know. And this is also why, by the way, comprehensiveness sometimes is a challenge. So, for example, what do I mean by comprehensiveness? So, let's say if you ask a model to list out all of the trials, or maybe you have your model connected to your internal data on file. I know of all of your FDA submissions, right? And you want to kind of ask the model to list out all submissions of a certain type or all trials of a certain type. The reason why it might not always return comprehensive responses is because, again, large language models are not logic models. They don't reason. They're purely correlating words that are near each other. So, for example, with the trials here, if I wanted to ask ChatGPT, what are all trials for Ozempic that are on clinicaltrials.gov? Likely, what would happen with a standard large language model is that when it was trained on, let's say all of the clinical trials text, it might see certain NCT IDs related with Ozempic. So statistically, it would generate text that might feature some of those NCT IDs, but it is not, in fact, necessarily always searching through clinicaltrials.gov, pulling all the IDs and then returning them, if that makes sense. So with that, one thing I wanted to also note, and this is the last point that was on the slide, which is I oftentimes see, folks get excited about ChatGPT because it is exciting in a lot of ways, but then presume that GPT is enough to solve all of their problems in the sense of, searching through all of the literature or searching through all, CRM notes for field medical and doing all of this analysis work all in one prompt. The reality is a lot of those use cases require multiple tools to orchestrate. And the way to think about it is think about getting some of these outcomes like field medical insights analysis. Let's say that that's an outcome. And all of us are familiar with the concept of recipes, right? So recipes have ingredients, steps to make the recipe, and the ultimate outcome, which is a delicious meal. So let's say like the field medical insights is the delicious meal, and it might require a few ingredients and steps to get there. So if you have a recipe, so to speak, that requires one ingredient, then ChatGPT is a good use case. So if all I wanted to make was steamed spinach, I just need spinach and then a microwave, right? And then I'm good. But if a recipe requires more than one ingredient or requires low to no hallucinations, high comprehensiveness, LLMs are likely just one ingredient in a chain of steps that you need to accomplish that outcome. So I think that is important to distinguish. So examples of when you could just use, for example, ChatGPT versus when it's not good to use. So ChatGPT, and I'm sure you guys have probably experimented with it in this way, but any sort of one-step processes, right? So summarize a paragraph, translate a paragraph, let me upload a PDF and give me a low fidelity summary that might not be comprehensive, may risk hallucination. So you have to keep that in mind. Those cases, as more like kind of a brainstorm rough draft, I think ChatGPT is great. And I leverage it that way every day for those purposes. When it's not a good use is anything that's multi-step, anything that requires low to no hallucinations, or anything that needs to be high fidelity, high comprehensiveness. So for example, the Ozempic, find all trials, you basically need to add also logical reasoning tools that will go to clinicaltrials.gov and will search all the clinical trials for Ozempic. And then they might leverage LLMs to pull some of the insights, but you have a comprehensive set that you're basing everything off of. So with that, another example, actually, I can kind of go through. The other point I want to make too is sometimes, we talk about efficiency with ChatGPT, but sometimes ChatGPT is just a solo tool, actually does not necessarily make your workflow efficient. So let me go through an example of a claims review for MLR, LMR, ad promo, PRT, whatever you might call the review process on your team. So on the left, you see a claim review, let's say if I only wanted to use GPT. And then on the right, you see a claim review that's more end-to-end automated that can more so enable efficiency. So if I was only using ChatGPT with a claim review, the flow might look something like this, right? I have promo mats open, I'm looking at a piece of collateral, there's probably some references linked. So I might copy the claim language into ChatGPT. I might upload, the reference file or that document to ChatGPT, and then I might ask ChatGPT, "Hey, can you find evidence that's in support of this claim?" Right? And you might risk hallucinations, and there might be missing evidence. But let's say ChatGPT returns something, likelihood you still have to go into that PDF, search through it to verify and double check, right? So honestly, like that whole process probably would take you longer than had you just open that PDF and Control F for like the evidence via the claim. So in that case, ChatGPT is probably not an efficiency gain by itself. So in this case, you'd likely want a more multi-step process that uses multiple kind of tech tools to automate the end-to-end. So for example, you might have a model that kind of automatically pulls all the reference and automatically analyzes the claims and in the collateral and kind of runs it and then shows you, the supporting evidence for the claim in line so you can see and verify a lot quicker and do it for the entire document. So that end-to-end automation likely will time, right? Versus just using ChatGPT. And you can think of this as the case for a lot of different scenarios. If you wanted to use ChatGPT to just analyze field medical insights from your CRM, maybe you pull a spreadsheet, you try to feed that spreadsheet into ChatGPT, maybe like analyze sentiment or pull categories, etc. You're still going to have to double verify everything. You're likely going back and forth, copying, pasting. It might not be as efficient as you might imagine. So with that, okay, but how can I use Gen AI? I know everyone always loves the use cases because I think it makes what AI can do tangible. And I know we're getting to this with, probably like 5 to 10 minutes left. So I'll try to go through all of this at a high level. And by the way, if any of these use cases you're interested in digging in specifically and actually seeing how to leverage ChatGPT or what you can do to enable it, like don't hesitate to ping me. I'm happy to dig into the weeds. I just can't with the amount of time I have today. So with that, okay. So I'm going to split up the use cases into two categories. There's the prompt only use cases where using just ChatGPT is okay. And then there's what I call AI recipes that likely require more than one tool to enable. So that way you guys know where you might want to start. So one example I have here, when people talk about Gen AI can go through volumes of data or go through publications or field insights, or generate SRDs off of your data on file, a lot of those scenarios are recipes. They're likely not, to get high fidelity, they're likely not just ChatGPT use cases. So with that, prompt only applications. So these are really good for kind of ad hoc or one-off rough draft type of situations. So if you want to upload a publication, download the PDF, upload it to ChatGPT, ask it for summaries or ask it for study design or what outcomes were measured. It's good for those types of applications. If you want to personalize emails, let's say as an MSL, you have certain KOLs or HCPs you're trying to target, and maybe you have a sense of their personas. Like one HCP is maybe more safety oriented, or one's always interested in MOAs, or one's always interested in how this impacts diabetic patients or patients with certain characteristics. You could leverage ChatGPT to help you personalize the same starting message into multiple personas, and it'll likely be a good first draft. You can use it to translate, obviously rephrase. A lot of the ways that I oftentimes use ChatGPT is as a brainstorming co-pilot. So even, for example, in like putting a presentation like this, like you could feed in to ChatGPT, hey, this is my outline. How do you think I should best transition between the different slides? Or give me ideas for how I can explain the differences in AI waves, right? Or differences in MOAs focused on a more lay audience versus a more technical audience. So those are really good examples for what I would encourage folks to just play around with and familiarize yourself with ChatGPT in that way. A lot of the other scenarios, and honestly, most of the scenarios that I think what IC Medical Affairs teams be interested in are more AI recipes, not really ad hoc ChatGPT prompting applications. So, all right, recipes, field medical, and these are all high level. I'm not going into details of the how. And again, I'm happy to dig in and actually showcase, here's prompt examples you can use, or here's what tools you would need to make this happen, and walk you step by step. Just ping me. I just don't have time. So field medical, things that Gen AI can be leveraged for typically as an ingredient in a recipe. Obviously, uncovering richer patterns of insights, so in the sense of you could have a tool that's plugged into your CRM that goes through and also takes in your medical objectives. Let's say you had 3 key medical objectives you wanted your MSLs to target in their interactions with a KOL, and you can have the Gen AI model effectively analyze all the notes against those objectives and how do they fit in. And this oftentimes can also help you identify, are MSLs targeting the right type of questions? Are they gathering the right type of insights? Because if majority of the insights are not targeted towards any of those objectives, then maybe there needs to be training to be done with the MSL team. So that's kind of one example. For Congress planning, where Gen AI can come in handy is if you're able to pull, whether it's presentations, abstracts off of the website or by attending a Congress, you can leverage Gen AI to kind of extract data from the PDF and then categorize it. Maybe you're looking for certain types of conditions, indications, agents, et cetera. So it can kind of better organize and clean up that data. So that way you can gather more market insights or create better reports or even plan for a Congress better before you attend. So ASCO, for example, which is happening now, right? There's like over 5,000 abstracts. That's very time consuming to have to go through manually. So you can leverage tools like ChatGPT or general automation to help you with that process. Obviously, analyzing ad boards and social sentiment, it's kind of a very similar use case to analyzing field medical insights. All right, so medical strategy. I think a couple of ways that you could leverage Gen AI from a medical strategy perspective is if you're able to aggregate various data sources that you have that are critical for medical affairs. So for example, right, your field medical insights from your CRM, your med info inquiries, even literature, maybe Congress abstracts, maybe internal data on file, which it needs to be organized and cleaned up in the right way for AI to understand. But if you're able to do that, then Gen AI in particular enables an easier way to be able to interact with that data. So you can ask ad hoc questions. If a competitor like creates or starts to talk about how their drug impacts sleep, and now your HCPs are asking questions about your drug and how it impacts sleep, wouldn't it be great if you can kind of search through your evidence and see what you might have to be able to support and educate on the sleep component that HCPs are asking about? The other ways you can leverage Gen AI that I feel like are particularly new compared to other waves of AI is if you do have access to things like patient registry data that's qualitative or EHR records that are de-identified, right? You will be able to mine that unstructured data, which could help enrich and identify unmet medical needs or information gaps. So you can tap into those data sources a bit easier than you were previously able to. And that kind of ties into the third point as well. And then similar to field, if from a medical strategy perspective, right, if you have certain objectives you're trying to reach on a quarterly basis and you're able to evaluate kind of the quality of the MSL notes as well as how those notes align with the strategic objectives, that gives you information about whether or not your MSL team needs to be coached in a certain way or needs to maybe dig deeper into certain topics. So it can really help just internal kind of empowering your MSL team. All right, so MLR or ad promo, PRT, PRC, whatever you guys might call it on your team. So there's a couple of ways that Gen AI can help in this, in particular when it comes to unstructured text, tables, and charts. Ignoring things like images or video content, that's a little bit harder to do today. But when it comes to more text, table, chart data, you can leverage Gen AI to help generate almost a dynamic claims reference library. I think one of the biggest time-consuming tasks of using claims libraries in PromoMats or any other kind of a CMS system you might be using for your review process is that you oftentimes have to maintain the claims and references, and that's very time consuming. So if there's a way to be able to automate elements of that with a high enough fidelity, that's certainly going to save a lot of time, not in general and also in the review process. So outside of that, I think if you're able to generate a dynamic claims and reference library, that can also help in enabling faster and higher quality medical or commercial content creation that's almost pre-reviewed before it gets submitted into MLR. So that way folks are spending less time actually reviewing and et cetera. So I do also have to jump off. I know we're running over time. So there's a couple of more examples that I have in here. I will share the deck. So for those that are interested, either ping me on LinkedIn or sign up on the bit.ly that I sent, and I can share the copy of the deck. And I'll have this recording, and likely I'll schedule more sessions as well, so we can dig into particular scenarios, and I can actually open up ChatGPT or show more AI recipe applications, so you guys actually get a tangible sense. So with that, I will give 1 minute for any sort of questions. So if you have a question that you want me to answer right now, comment or forever hold your peace, and I'll answer one question if anyone has one. I know Vivek, you asked about updates to Gen AI technology on the horizon that you're excited about that will unlock even new medical affairs opportunities. Honestly, I feel like with our current AI capabilities, we're at where floppy disks and dial-up was back in the day. So I feel like we haven't even really fully integrated the full applications of Gen AI. It's been over 500 days since ChatGPT went viral, and I still haven't. Medical affairs is integrating it slowly, but I think we're just at the start. And even beyond LLMs, I actually think what's going to make the most impact is not LLMs. I think it's going to have to be a fundamentally different AI architecture that's going to unlock new levels. So, all right, William, your thoughts on ChatGPT 4.0 versus 3.5. So it kind of, in a way, depends, William. I mean, 4.0, I would say, generally from like a lay perspective, tends to be more accurate. It's more expensive than 3.5. So I think ultimately the way I would approach distinguishing those two would be to evaluate it on a use case basis. So for example, if you're trying to extract patterns from field insights, I would take 100 insights and then I would run 4.0 against those insights and 3.5 against those insights, and then create criteria that determine what good looks like, and then evaluate based off of that. And maybe 3.5 is better, so then you would just use that, or 4.0 might be better. Ludovic, any concrete AI implementations in biopharma? Yeah, I'm happy to share offline a couple of examples, and I'll probably do a separate session where I just like dig into actual specific use cases and like show you guys through ChatGPT, so you guys see it happening for yourself. So Ludovic, if you want to, or I might have your email, I'm happy to reach out, or if you want to DM me on LinkedIn, I can share specific examples as well. Yes, thank you, Christian. Appreciate it. I agree. I think there's so much opportunity for AI to be integrated. I just think it has to be done in the right way with the right knowledge, but we'll get there. Hopefully by next year, we'll be having a different conversation. All right. Well, thank you guys for joining. Recording will be shared and there'll be more events like this. Hopefully you learned a lot through this, and don't hesitate to ping me with any questions. All right. Thank you guys. Take care.